The future of nuclear waste and industry needed innovation. This is a presentation of Group B in our capstone project. The team is consisting of 4 individuals. Kenneth Freeman, who is the project custodian. Miranda Tilley is responsible for reporting on the management of nuclear waste in the past. Perry Sadowski is responsible for reporting on the management as it pertains to the present. And myself, Patrick Carroll, is responsible for reporting on the future of waste management. And Perry Sadowski, with the previous segment of this, gave us an insight on how we are currently dealing with waste in the present and what we need to do to move forward into the future. We will be covering the projected amounts of waste that were to be generated in the coming years, methods to dispose of this waste, environmental and social concerns, a conclusion, followed by a page of references. There are basically 2 main types of nuclear waste. There is the low-level nuclear waste, which is the majority of all waste generated. It consists of not only material from the nuclear power industry, but medical institutions, mining byproducts, and other materials. This accounts for about 97% of all waste generated and 8% of the activity. And then our biggest area of concern in the industry is high-level nuclear waste. It is the area of largest concern due to its high activity levels and continued decay heat production. And this waste is generally spent fuel and byproducts from the reprocessing of some of those spent fuels. As waste continues to be produced as we move forward into the future of the industry, low-level waste will continue to be generated on an as-needed basis. Now, with likes of waste cleanup, spills, production work, different things. Those are things I encounter in my daily work schedule. As far as high-level waste is concerned, though, in the last 40 years, we have produced 74,000 metric tons, and we are projected to produce 2,300 metric tons per year moving forward. So obviously, as we extrapolate and hopefully continue that the industry continues the renaissance that it is currently seeing, that we are able to innovate and come up with some methods of being able to dispose or store this waste in a better fashion. Now, why do we need to innovate, though? Now, if you look at the map on this slide here, this shows a lot of the areas in our country that have high-level waste stored, spent fuel pools, and notice how they're spread fairly well throughout the country. And now most of this is currently destined for geologic storage. Hopefully Yucca Mountain, if we can ever get that back online. But as we continue to produce, we will start to run out of space. Now, there is a lot of on-site storage after being used in spent fuel pools. After a good portion of decay heat is removed, there'll be on-site cask storage above ground. But the goal is to hopefully be able to move all this stuff off-site and put it in an area where it's safer and out of the hands of the general public. And this definitely came to light in March 11th of 2011 when Fukushima suffered a meltdown on its operating reactors. Now, unit number 4 was not online at the time. It was being refueled, and it had 1,331 fuel assemblies in its spent fuel pool. And it incurred a dangerous loss of water level because through the circulating system, it almost uncovered the fuel. If you look at the picture on this slide, this is actually a picture of the damaged spent fuel pool at Fukushima. So that brought that into the spotlight for society, and they understand that, hey, maybe we need to figure out how to do better storage processes with these things, so in the event of a tsunami or an earthquake or even a terrorist attack possibly, that we don't run the risk of spreading this spent fuel out into the environment. Some of the ways that we can innovate the industry sound a bit far-fetched, almost like a little bit of science fiction, but they're very interesting. A couple of them that I came across, 2 are more than likely either permanent disposal methods, although there are options to be able to retrieve it based on what conditions you may use. And then a third is actually a reuse of spent fuel, which I found the most interesting. We'll talk about these as we move on through the slides. Subsea floor waste disposal. It would place waste in seismically stable areas within the ocean seabed. It allows for deep burial more than 5 kilometers below the surface. And this takes into account the depth of the ocean prior to reaching the seabed. So this will keep us well out of the public's backyard, as the saying usually goes. And packing it down there in the seafloor bed will be clay-rich sediments that's ideal for storage and even absorption as the canisters begin to decay over years. And as it stands now, a lot of the oil drilling technology that we have for deep sea drilling could be used for this. There will need to be innovations as far as storage vessels and the life cycle of those storage vessels, but those are still being researched. Currently, there was a 25-year moratorium put in place back in 1998 on this type of exploration. I know that it's being worked behind the scenes, but actual on-scene theory to practice, as far as being able to look into ideas and using prototypes, has not been allowed to be conducted. But as we're near that 25-year moratorium, we should be able to get back into this type of disposal and see what it could hold for us and the industry as a whole. The next methodology we come across for disposal options is space. I know that sounds a little bit out there, but it's a very interesting concept. Obviously, there's problems with this that people want to go, well, we just don't want to launch our waste into space to figure out where and not know where it's going to necessarily go. But the two papers I came across for this, one was written by NASA and the other was written by Mr. Coopersmith. NASA's dealt with primarily using rocket launch technology to put waste in either a lunar orbit, soft landed on the moon, put it in orbit between Venus and the sun, or put it up to such a velocity that it would escape the solar system. Obviously, in most of these, they would not be allowed for retrieval if somehow in the future generations were able to figure out technology where they could harness our used waste and get more from it. But it is an interesting take on that. And the other was a laser launch system. This system basically uses used initially a 10 kilowatt laser, and it was able to boost a 2-ounce object 60 meters vertically into the air. Essentially what it does is that the bottom of the capsule is hit with the laser, and it heats up the solid fuel and causes the resultant explosion, thereby allowing the vehicle to leave. Now this one, cost is obviously a concern, but as we adapt the technology, it should be very promising. Maybe being able to use actually use this to transport individuals off planet as well. Now both of these concepts, there's a lot of engineering involved still with proper storage capsules and being able to allay fears about if you have an issue such on the launch pad, what are you going to do? Obviously, we don't want to blow up a rocket with high-level radioactive waste on board. So they are still working through these things to try to figure them out. And the other one I came across, which is very interesting, a company named Transatomic. It is a molten salt reactor. Now, this is an adaptation from 1960s technology that was used at Oak Ridge National Laboratory. Now, that one actually operated for 6 years. Then it was shut down because they thought it was too expensive. And then we moved on to basically boiling water or pressurized water reactors, which we see mostly throughout the world. Now, currently they are using computer-based model testing to ensure this is a proof concept and it works. And aside from is that when we use this process, it will only generate 4 kilograms of high-level waste and 250 kilograms that we need to store for a couple of hundred years, as opposed to the metric tons that are generated by the current plants. And this is a very interesting concept that it basically superheats the salt and combines used uranium pellets from operating plants in the salt, and as it heats up, the reactions occur, and it's their design is inherently safe because it is modeled to fall apart by a freeze plug in the bottom that if it needs to be dumped, the plug will melt and it will all go into tank, and as the salt expands and cools, will the fuel will settle out and the reactions will shut down and the reactor becomes inherently safe. I find this a fascinating concept, and hopefully Transatomic can bring this to market. This is fascinating. Now, as we move on to environmental and social concerns, obviously we have our typical problems that people are worried that there'll be accidents in their backyards. Um, they're going to be put in areas where there's a large socioeconomic gap. Put all the trash where all the poor people are. We don't want that to occur. And there's just a general lack of education for the public about waste storage and nuclear power in general. My favorite adage, as I used to from teaching many classes while I was in the Navy, was, I can operate 8 reactors safely in downtown Newport News, and the people 2 blocks away don't even know what's going on. That was always it's kind of funny, but it's very, very interesting. Now, are people right to be concerned, though? Now, in February 14th of 2014, there was an incident at the waste isolation processing plant that resulted in the release to the environment and internal contamination to individuals. And they were contaminated with americium and plutonium. And this was due to a faulty mixture in one of the storage casks, but it escaped the environment, and was detectable outside of the plant. And another issue, as we talked about, as far as the socioeconomic was concerned, in Bridgeton in St. Louis, there's a subsurface fire that's currently been burning for probably about the last 10 years that is now within 1,200 feet of an EPA Superfund site, and that is the Westlake landfill, where 40 years ago there was a lot of illegal radioactive waste that was dumped. Some was even from the Manhattan Project. But as this fire continues to burn, they're trying to ensure that it doesn't reach the Westlake area, thereby causing a radioactive fire, which obviously would result in the release of contaminants into the atmosphere as material burns. In conclusion, we see some of these innovations as we move toward the future. I know we understand whether the past or the present, management of the waste has been a concern. Since we first split the atom, we've had to figure out essentially where we're going to put the trash. But with continued innovation and research, and through well-thought education to the public, we should be able to develop new technologies that will allow the nuclear renaissance to continue for years into the future, to allow for a sustainable, low-cost power for the world. Thank you for your time, and have an enjoyable day.